for the next few days, we're going to be talking about light. Okay, we're going to just talk about light. And we need to figure out, number one, why is light so important for astronomers? Actually, you know what? I'll go ahead and ask that to the Discord. Why do we have to spend so much time talking about light? Why is it so important in astronomy? Think about it. You can use it to measure things. That's good. That's good. And we'll be talking in this section about how we do that. But why is light probably even more important to astronomers than other sciences? Let me walk you up this. Yeah. So we need it to see things, and the distances to the stars is very big, right? We need it to see things, and the distances to stars is very big, right? So let me put it this way. Let's imagine you're a chemist, right? Let's imagine you're a chemist, okay? And let's say you study, I don't know, acid or something, okay? You're a chemist, you study acid. What is probably the first thing you're going to do, okay? What is probably the first thing you're going to go get? What you going to go get? You're a chemist, you study acid. What are you going to do? I'm going to go to the acid store, right? I'm going to go check out some acid, right? I go get like a big bottle of acid, and I do my chemistry acid on it. Whoa, like, ow, okay. That's chemistry, right? Sorry to all you chemists out there. Okay, let's say you're a biologist, okay? Let's say you're a biologist and you study, I don't know, dead rats or something, okay? You're a dead rat biologist. What are you going to do? What's the first thing you're going to go do? What you going to go do? Yeah, you're gonna go get some rats, right? You're gonna go find some rats. You're gonna make them dead rats. Not gonna go into that. You're just gonna take some rats, turn them into dead rats. Get you a big bag of dead rats and do your dead rat science. All about them rats, right? That's biology, okay? But if you're an astronomer, right? If you're an astronomer and you're studying, let's say, Saturn. Let's say you're studying Saturn. What are you not going to be able to go get a big bag of? What you're not going to be able to go buy a big bag of if you study Saturn? You can't go get some Saturn, right? You can't go get some Saturn. So you're stuck. You can't do your big bag of Saturn science, right? So basically there's a big difference here between an experimental science and an observational science. In an experimental science, you can really do a lot of hands-on experiments. That's why it's called experimental science. Whereas astronomy, because most of the stuff we're studying is just way too far away, we would like to get our hands on it, but we can't, right? So the only way we can study other stars, or even just the sun or distant planets, is just by looking at it, right? So that means that everything that we have learned about galaxies and black holes and all of that kind of stuff and supernovas, that's all just from looking at it. And that means that all of the information we've ever learned has just come to us on light, right? And so that means that the study of astronomy, our basic only tool for almost all of it, is just light. And so that means we need to know, how can we figure out a bunch of stuff from light? Because we don't care, we do care what things look like, but if we just cared what things looked like, that wouldn't tell us very much at all. For example, if we find a planet or a star way out there, we can actually figure out what is that star made out of, just from the light. Not just, it looks like oxygen. It doesn't just look like oxygen. We know it's made out of oxygen based on the kind of light it's giving us. So basically that's what this whole chapter is about. And if you want to follow along in the book, this is going to be chapter 5. Okay, this is our final chapter for test 1. Okay, so chapter 5 is about light. And let's get into it, okay? So, here we go. We actually already started talking about light a little bit. There are two major ways to talk about light, okay? Two major ways to think of light. And one of them was a stream of particles. And this we talked about last time. Does anybody remember what those particles are called? What's a particle of light called? If you're going to think of light as a stream of little particles. What's a particle of light called? Talked about that, I think, last time. Yeah, photons. Photons. Photons are particles of light. So that's one way to think of light, as a stream of little bits of light called photons. But there's another way to think of light, right? There's another way to think of light, not as a stream of particles, but instead as something else. Does anybody know? Any of you guys know what the other way you can think of light is? Yeah, I'm trying to hint here. Yeah, the other way to think of light is as a wave. Okay? As a wave. Okay? So, and there was actually a giant debate on this for a long time, okay? There was a giant debate on this between one group of scientists who thought that light was a stream of particles and one group of scientists that thought that light was a wave. And they got into arguments about this for a long time. At first, it was, cordial. It was just nice arguments where we're just, debating. But some of the meetings that went into the arguments between these two types of light, or these two ideas of what light is, actually erupted into actual fistfights and barroom brawls. Like, people were punching each other like, light's a particle. No, it's a wave. Pow, 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 pow. I mean, people got really into it. I wouldn't be surprised if people lost an eye or something like this. Like, you think light's a particle? Well, now you can't see anymore. I mean, I don't think anybody died over it, but I don't really know. I mean, it's possible. It got real, right? And then after a long time of arguing about that, we realized it's both. It's a stream of particles and it's a wave. It's like, we're all right. We're all right. It's both a wave and a stream of particles. However, almost all of the important information that we can learn in this particular section that we're going to talk about comes from the wave nature of light. So let's talk about what light is, okay? Light is a wave, all right? But it's not the only kind of wave. Give me some other waves. Give me some other wave. What are some other things that are waves other than light? What are some other kinds of waves? Or anything that is a wave? Sound, that's a good one. Water, that's a good one. You could have just a wave on like a spring or something, or a string, right? Like if you whip a string up and down, it'll cause a wave on that string, right? Oh, this is a wave. Yeah, that's a wave too. You probably heard of the wave, right? Okay, so what do all those things have in common? They're all waves, but what makes something a wave? What has to be happening for something to be a wave? There has to be a certain kind of motion. Yes, there has to be something. There has to be some kind of motion, but it's a specific kind of motion. You kind of think of it right. It's something going back and forth, right? So like right now, this is a wave because my hand is going back and forth, right? Think about ocean waves. In an ocean wave, what's moving back and forth in an ocean wave? You guys are getting real technical down there. Think of less fancy. What's moving back and forth in an ocean wave? Like what substance? Water, right? It's just the water is moving back and forth. Water is moving up and down and back and forth. But it's a repeated motion, right? It's a repeated motion. If you had a wave on the string, by shaking the string, it would just be the string going up and down, right? It's that back and forth motion. We won't really get into sound waves. Well, actually, you know what? Screw it. Here's what sound waves. Does anybody know what's moving back and forth in a sound wave? What physical substance right now? Like I'm making sound right now. The air, yeah. Right now, it's the air. So right now, my vocal cords are moving back and forth. And that's basically pushing on the air in front of my face and making it move back and forth. And that back and forth motion is moving across it faster than that. And eventually that gets to your head and jiggles your ear, and that's when you hear me, right? And that's why, if somebody's like across a football field from you, if they're on the other side of the football field and you shout at them, they can see you moving and then later hear you because it took a while for that jiggle to get across the football field, right? And that's also why if you're in a vacuum, you can't hear because there's nothing to jiggle, right? Now, that said, here we go. We're talking about light, though, right? So let me see if anybody knows. I don't really expect you guys to know this, but let's see if anybody will give it a try. Does anybody know what is waving back and forth in a beam of light? In a wave of light, do you guys know what is actually waving back and forth? If the answer is no, just give me a no. You don't know. So I can move on. So do you guys know what's waving back and forth? No. Typically, we don't really think about light, right? We use light probably more than any other wave, but it's another one of those things where you don't really need to know how it works to use it for everyday purposes. But we do need to understand how it works to get more information out of it. So, what's waving? Let me give you guys a hint. That's kind of a trick question because it turns out there are two different things waving in a beam of light, okay? Two different things. It's what's known as a complex wave, because we have two different things waving in two different directions. But to give you guys a big hint on what they are, let me tell you the full name for light, like the technical name for light. And I'll write it down over here, okay? So here we go. It's called, oops, have my sound on. Sorry, guys. There we go. It's called, and of course, it freezes up right when I want to write on it. Give me 1 second. Restart, as always. Okay, so the full technical name for light is electromagnetic radiation. Electromagnetic radiation. That is the full, let me zoom in on that a little bit. That's the full technical name for light, okay? And actually, this is frequently abbreviated. A lot of times people will just say radiation. So another word for light is just radiation. Let me get this out of the way real quick. Is radiation dangerous? Is radiation, a lot of people are scared of it, is radiation dangerous? Yeah, you guys are getting this right. It can be dangerous. Some radiation is dangerous. All the word radiation means is light. So some people are afraid of radiation. That just means they're afraid of light. So clearly not all radiation is dangerous because like right now, there's light coming off of your screen, right? There's light coming off of your screen at you. And you're using that to see. We need radiation to see with because we need light to see with. So yes, some of it is dangerous. And we'll talk later today, hopefully, about what makes some of it dangerous, okay? But, here we go. We're trying to figure out what is actually waving, okay? What is actually waving? And I said there's two things that are waving, and I said that this name is a clue. So let's figure this out. Can you tell me at least one thing that's waving in a beam of light? If this name is a clue, this name should clue you into actually both of the things. The first thing is in an electric field. The first thing is in an electric field. Can you figure out what the other thing is? Yes, a magnetic field. A magnetic field. So the reason light is called the reason light is called electromagnetic radiation is that when a beam of light flies by, what you've actually got is an electric field waving up and down, or it doesn't necessarily have to be up and down, but an electric field waving back and forth. And at the same time, a magnetic field moving back and forth. Okay? And they wave at the exact same rate. Okay? So, for example, if the electric field was coming by like this, at the same time, you'd have a magnetic field going like this. So can light be bent by a strong enough magnet? We'll talk about that. We'll talk about that a little bit later, okay? Now, check it out. But yes, things that can affect electric fields and magnetic fields can affect light. I'll say that, okay? So yes, things that affect electric fields and magnetic fields can affect a beam of light, okay? Just in complicated ways. Now, check this out. Here's the thing. Let me see if I can do this kind of coming into the camera here, okay? Actually, do I have a... There we go. Okay. So, right now, imagine that the electric field is going like this. So, let's imagine the electric field is going like this. If the electric field is going like this, then the magnetic field would be going like this, okay? At the exact same rate. So, let me see if I can do this. They would be doing this. Okay, this is kind of hard for me to do, but you see what I'm trying to do here? One of them waves up and down, while the other waves left and right. Or, like this. They're always at a 90-degree angle. Here we go. This is bad. Normally I do this in person and it makes more sense. Here we go. Okay. Let me show you a picture. Here we go. So let's say that was the electric field going up and down. At the same time, the magnetic field would be going in and out of the page at the exact same rate. So in and out. The important part is this. You've got an electric field and a magnetic field waving at the same rate. So usually we're just going to draw a simple wave like this, and just remember that it's both an electric and magnetic field that is waving.